Okay,
So,
finding your distance. JK, you have to unfreeze it. See, it's just like they're here.
Wait, are they listening now?
Okay, yeah, it's recording.
Alright.
So we got the square root of 3 minus negative 2 squared plus negative 2 minus 9 squared. 5 squared is 25. That'd be negative 11 squared, so 121. Easton, 25 plus 21? 121.
25 plus 121?
Yes.
146.
Thanks, buddy. Alright, not a perfect square. If you have one of those fancy calculators, it'll simplify it for you. Did yours go down any further?
I missed it somewhere.
Okay. Does yours do that?
If I made it, yeah, but it just...
Okay. What's the decimal?
Like 12.6 or something like that.
12.083.
Oh, never mind.
Close.
Well, somewhat.
Alright, on the next one, setting it up the same way, we're going to have negative 3 minus 1 squared plus 5 minus 3 squared. Negative 4 squared is 16, 2 squared is 4. Looking at the square root of 20. Thank you. Yeah, so there's Bauer. Alright, go ahead and get out homework, because we're going to grade.
That's from trolls.
Okay, so if you have a problem like this, and you're asked to solve for x, and I've given you two equations here, that 3x plus 3y equals negative 3, and that y equals negative 5x minus 17. One way that we could go about doing this is that this y right here can be replaced with all of that. Okay. What that allows us to do is now write this equation as 3x plus, now will this 3 right here still be part of the equation?
Yes.
Yes, instead of the y, what are we going to write down though? Okay. And then equals negative 3. At this point, is x the only variable in that equation? Okay, so then this is algebra 1 and you just solve it and get x by itself. Okay. So Carly, if we wanted to get x by itself, what would you do first here?
I distributed 3.
Agreed. Okay, so 3 times negative 5x.
Negative 15x.
And then 3 times negative 17.
51. Negative 51.
Negative 51 equals negative 3, and we still have this 3x out in front. Mr. Cohagen, on the left, if you combine x's, what does that give you?
Negative 12.
Okay, so we have negative 12x minus 51 equals negative 3. Dylan, from there?
That'd be negative. Well, that'd be, what would that be? That'd be 48.
Because you're adding 51 over, yes. Okay. So you have negative 12x equals a positive 48. Dividing both sides by negative 12. Cody, what would your final answer be? Good. Okay. Good. Is everyone okay with how we replaced y with an equation that we had?
I missed algebra 1. That was my favorite. Yeah.
It was a good time, wasn't it?
Yeah.
Oh, the nostalgia of it. All right, Lacey, are you okay with this? All right. Okay, so let's look at another example like that. If I gave you 3x minus 2y equals 4, and that y equals x minus 1/2.
Isn't there also a thing where you can like make your x's the same or your y's the same and that row cancels out?
Yep. That's systems of equations.
Oh yeah.
And yes, that's the elimination method. What we're reviewing here is the substitution method. And I'm reviewing this because this way is going to help us with the word problems that we're going to be doing today. Yes, ma'am. Yeah, go ahead. Leave your phone, please. All right, now, down here, what are we going to do with this x minus 1/2? Plug it in where?
Y.
On the first one. So this is going to look like 3x minus 2, and then in parentheses, x minus 1/2, and it equals 4. Does everybody understand how we're replacing the y with the equation there?
Mm-hmm.
Okay. Oh, give an answer. 5? Okay. Let's see if I remember. 3x minus 2x plus 1 equals 4. I think you minus 1 over, so I think I'm going to go with 3.
Oh yeah. I had a minus 1.
Silly girl.
But a negative times a negative makes it a positive.
Yes.
Okay. Easton, you feel okay? How about with this algebra?
Absolutely.
Good, because we're going to do word problems, which I know you'll hate, but as long as you're good here, I feel like we can go on. Okay, so let me get you the notes for this. Clear off your desk except for a writing utensil, please. One's for you and one's for me.
Well, you sound so professional.
I don't know what you're talking about, Easton.
You sound like the count from Sesame Street.
Ooh,
I was listening to this, I'd be cracking up.
I got 1, 2, 3, 4, 5, 6, 7, 8.
Have you seen Muppets on my street? Count, and he's counting, and then he comes along, somebody's asking.
We have, you already
I have all these extras, so many people are growing. Okay, looking at this one, we're going to let P be an ordered pair, x comma y, on a point of the graph of y equals x squared minus 1. And we want to express the distance, d, from P to the origin as a function of x. Woo! A lot of fun stuff going on there, right?
Wait a minute, what are you writing?
Nothing for the moment.
Yeah, you have to write it in the.
How about that y equals x squared minus 1?
That's what I was talking about.
Okay. Dylan, graphically, what does y equals x squared minus 1 look like?
That's the parabola.
That's been shifted which way?
Down.
How many?
1.
Good. All right. So let's go ahead and just draw a sketch of that. All right. So if you have a parabola that's been shifted down 1, okay, so our vertex is starting at 0, negative 1. Then we go up and over 1. Then we'll go up 3, over 1, both directions. Okay. So we know that this is our graph. Y equals x squared minus 1. Okay. What we're being asked to do is to express the distance from a point P to the origin as a function of x. Now, P is just a random ordered pair. Do we know exactly where on the graph this ordered pair is? No. Okay, so I'm just going to say it's right there. That's the point P.
We can pick any point.
We can pick any point because since it's positive x and positive y, I'm picking it in the first quadrant where both x and y are positive. Well, the origin is the other part of the problem, Cody, because they want the distance from a point anywhere on the graph to the origin.
So we can just make it like 1, 0 every time?
No, you cannot, because you have to be able to write a function of it, which means we're writing an equation.
I like this now.
All right, now, what we're being asked to write is the distance of that line. Okay. Do we have a formula for distance?
Yeah, I just
Yes.
told you earlier.
Would you mind saying it again?
Isn't it like d equals the square root of x2 minus, x2 minus x1 squared plus y2 minus y1 squared?
Very good. Okay, so with distance, you always need two ordered pairs. What's one ordered pair that we've been given here?
0, 1.
0, 0.
1, 0.
The origin,
Yeah. How did
0, 0. I just picked it anywhere on the graph. They told me to use P equal P x comma y. We don't know what it is. That's what makes this difficult, because we don't know
So
the
you
other
don't
ordered
want
pair.
an actual point?
It's not going to be a number.
Okay.
Okay, they're asking us to express the distance as a function, and if you're being asked to write a function, you're being asked to write an equation out.
Okay.
So it's not going to be a set number the way it was with the bell work. It's going to look like a big, long, hairy equation.
Oh, dang it, I did that wrong.
All right, so if one of our ordered pairs is 0, 0, and our other ordered pair is x, y,
Oh, we have to do that thing.
plugging this into our distance formula, we have d equals the square root of x minus 0 squared plus y minus 0 squared.
X squared plus y squared.
Agreed. Okay. D equals the square root of x squared plus y squared. Now up here it says as a function of x. So what's the only variable that we want to have in our equation? X. That means we need to get rid of something. What do we need to get rid of? The y. Can we replace y with anything that we know about? What? Very good. We know that y is x squared minus 1. Okay, so we'll come down here and we'll write d equals x squared, that one's fine because it's already an x. But then we are going to replace y with x squared minus 1 squared.
Why is that squared?
Because the y was squared, and then his is the y, but the squared's still there.
Okay.
Alright, now, Easton, that is a binomial. When you square a binomial, what do you get? Yes, you get a trinomial. That would be correct. Okay. Carly, can you square x squared minus 1 for me?
X to the 4
Yes.
minus 2.
That's not all of it.
Oh, no.
No, that's part of it. Anybody want to finish that off? There's something else missing in the middle.
Next.
X squared
Squared.
plus 1.
Okay.
Okay. So all underneath this square root sign, we've got d equals the square root of, all right, now combining like terms, if you have an x squared and a negative 2x squared, what would that make? Negative x squared. And then we have that x to the 4th minus x squared plus 1.
So, what's the answer here?
Well, at this point, is x the only variable in your equation?
No.
Yeah.
X.
Oh, I thought you meant like because x is going to
Yeah.
minus x to
But that's, it's fine as long as x is the only variable.
the. Okay.
It doesn't matter what exponent it's raised to or if it's underneath the root. As long as x is the only variable, then you are done. Now technically, function notation would be to write it as d of x, just like we always write f of x, g of x, all the good stuff. So the distance as a function of x equals the square root of x to the 4th minus x squared plus 1. Okay? That is your answer for part A. Uh-huh.
So, where did you get the x squared minus 2x squared plus 1?
Right here at this part.
Yeah.
When we replaced y with x squared minus 1, see how this y was squared? So that squared is still here. And then if you have a binomial squared, it becomes a trinomial. Your first term squared, your last term squared, and then 2 times the terms in the middle. Okay, so that's where that came from. This trinomial is the binomial FOIL out.
And then you just take those two.
Because they're both x
combine like
squareds.
terms.
Yep. And an x squared and a negative 2x squared gives us the negative 1x squared. Then there's still that x to the 4th and the plus 1. What, Ashley?
I think you just explained it, but you also learned it with the negative 2x squared. And
Mhm.
then go from that to just negative x squared.
Sure. Combining like terms. Here is a 1x squared, and here is a negative 2x squared. They're both underneath the same root, so we can combine them. It makes negative 1x squared. Okay. All right, so that gets us a function. Now on part B, it's asking what is d if x equals 0. So that's asking for d of 0.
So we can just take that problem and the 0.
Exactly. Okay, so you take the function we just came up with, and you plug in 0 for all of your x's. So, Cody, if you plug in 0 and take it to the 4th power, what does that give you? And if you take it squared, what does that give you? And then there's that 1. Okay. So, underneath, what's the square root of 1? There you go.
So how would you answer it? D of 0 equals 1?
Good. D of 0 equals 1. Now, Gracie, if I asked you to write that as an ordered pair, how would you write it? If it's in the parentheses, that's your x value.
Yeah. You said it right.
No, she didn't. Backwards. 0, comma 1.
Wait.
1, 0.
It should be 0, comma 1.
I thought that was x.
Whatever's inside
Yeah.
is your x value,
Okay.
and an ordered pair is always x, comma y. So 0, comma 1.
Okay, I see.
All right, now on part C, what is d if x equals 1? Okay, so that's asking for d of 1. So if you plug that in, you have 1 to the 4th minus 1 squared plus 1. Well, I agree with you.
Hey, this poses tomorrow's.
This is today's. This is what we're doing right now. These are our notes.
Okay, I got you.
All right, so Matt, I'm not going to move on. Get that written down. I'll do the last part just on the side here. See if I can squeeze it in. And now on the last part, I believe it is asking for when x is it the square root of 2 over 2?
We don't have it on ours.
We have x equals.
Like X equals.
Let's just make it the square root of 2. So we want to find d equals, or excuse me, d of the square root of 2. Now, when you plug that in, so underneath your square root, you've got a square root of 2 to the 4th minus the square root of 2 squared plus 1. In the middle, what's the square root of 2 squared? Oh, stop that. Put those calculators away.
It's 2.
It's just 2. Squares and square roots undo each other? Yeah. Okay. So that's a 2. Now, if you have the square root of 2 to the 4th, when you squared it, it was 2. So what happens to when you take it to the 4th? You get 4. Okay? So underneath, you've got the square root of 4 minus 2 plus 1. What you got?
3.
3. Now, that's still underneath the square root sign. Can we do anything with the square root of 3? No. All right, so on that last one, d of square root of 2 equals the square root of 3.
So it would be square root of 2 comma square root of 3.
Yes, if I asked you for an ordered pair, it would look like the square root of 2 comma the square root of 3, because it's always x comma y. Huh? Questions on this one?
It's not that bad once you get like the first
Once
part.
you get, yes, the first part is the
Just
hardest
plug
part,
it in.
getting your equation. Everybody have what they need?
No.
Okay.
Where's the last
So
part?
weird.
This side over here.
Yes, this over here. The d square root of 2.
He's been wearing tennis shoes for like the past couple days.
It's his feet hurting.
The square root of 2 to the 4th is 4.
Yes.
That's 16 and the square root is 4.
I think that's how that works.
Yeah, you can do it that way too.
Wearing the shoes, bro.
Take ibuprofen, bro.
You okay?
Every day, bro.
Cody, can I go on? Okay, so on the second example, on your paper, a rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared. That's what you write down.
On the second one. 25 minus x squared.
Another at the origin, a third on the positive y-axis, and a fourth on the positive x-axis.
I hope we don't have that one really extra.
Huh?
We do. Willy-nilly.
What is 25 minus x squared?
X minus 5 times x minus 5.
Can also be written as negative x squared plus 25. So if you think about transformations, what has that done to your parabola?
Flips it.
And what does what else?
Moves it right.
Up 25?
Yes.
Okay. So in this case, your parabola looks like 5, 10, 15, 20, 25. And then it's opening down. Okay. What would the x-intercepts for that parabola be?
There isn't.
Y.
Why?
Mm-hmm.
Oh.
So it'd be negative 25 equals negative x squared. You can divide that by negative 1, so it'll be 25 equals x squared. If you square it, that'd be 5.
Oh my God!
And negative 5, but yes.
Yes, that is true.
Say what? I don't know. I heard it's 5 squared, b squared 5, and then, yeah, 5.
I asked, transformations tell us that this is going to be a parabola that's opening down because of the negative, and up 25 because of the plus 25. It's also kind of nice to know where your x-intercepts are going to happen at. And if you ever need to find x-intercepts, you replace 0 with y and solve for x, which Gracie did out loud. So if you have 0 equals 25 minus x squared, add the x squared over, square root both sides. So I know it's crossing the x-axis at 5 and negative 5.
Hold up.
Just having a slightly better graph, that's all.
Gotta fix this.
But it said it a dot origin.
There is, yes, because what are we drawing inside of this parabola?
Square.
A rectangle?
Yeah.
Okay, so we're drawing a rectangle inside this parabola. This rectangle has 4 corners. One of them happens where? At the origin. Okay, so right here. That's one corner of my rectangle.
Okay, hang on, I have a question. Why did we decide to draw a parabola?
Because that was the graph they gave us. If they had given us y equals x cubed plus 1, we would have drawn a cubic.
Okay.
It's got an X
I
squared
guess,
right there.
why is the I mean, I know it's a rectangle in the problem, but why?
That's the problem.
That's just how they wanted to do it.
That's the problem they're giving us, Gracie.
Oh, I got that. I don't know. Okay.
You're being
A
difficult.
rectangle has one corner in quadrant 1. So which quadrant is that?
Top right.
Top right. And it's on the graph of y equals 25 minus x squared. So somewhere on this piece of the parabola, there is a corner of the rectangle. I'm going to put it here. I completely arbitrary. I just randomly picked that.
Third on the positive y-axis.
Now a third on the positive y-axis. So if we want the positive y-axis, would that be the top half or the bottom half? Top. Now it is a rectangle, so it has to be perfectly straight over from there. Now the way that mine's drawn, it kind of looks like it's landing at a nice point. Is it guaranteed to be at a nice one? No, it is not. And then a third on the positive x-axis, which would be
Oh, it says the fourth.
fourth. It does. Okay. But then we've got our rectangle there.
So we don't have that know like the exact points.
Nope. That's why this is able to work, because we
just
don't
have
know
to
what they
draw
are.
it the way we need to.
Now, put your pencils down for just a moment and look up here.
Well, I haven't finished drawing yet.
Okay. I picked that point arbitrarily. I could have picked it to be way up here, and then my rectangle would look like this. Okay? But it would still be a triangle in the first quadrant, on the parabola, on the origin, on the positive x-axis, on the positive y-axis. We also could have chosen to pull the point all the way down to, here. Then the triangle, rectangle, would look like this. So where we picked this point on the parabola piece doesn't matter. It just has to be in the first quadrant, because they told us that. Okay. All right, now, pick up your pencil again. It wants us to express the area A of the rectangle as a function of x. Well, how do you find the area of a rectangle? Length times width. Okay, now, this would be the width. But what might be a better variable to use instead of w? X, because we're on the x-axis. When you go left and right, that's your x. So I'm going to say, okay, so that represents x. And then my length, maybe instead of L, what might be a better variable to use? Y. Okay. So then the area for a rectangle can be written as x times y. Instead of L times W, X times Y.
That's your answer.
It is not. Why not? Why can't we just be done with it at this point? Good. It needs it to be a function of X, which means what's the only variable we want? If X is the only variable we want, what do we need to get rid of? The Y. Is there anything up here that gives us something else to plug in for Y? Good. Okay. This 25 minus x squared, this thing right here, that's what we will replace our y with. So we'll write A equals x, open parentheses, 25 minus x squared. Ethan, write it down. Okay, now distributing that x through, that's going to look like A of x equals 25x minus x cubed. This x that's right here, the A of x, that's just putting it in function notation. It's just saying that the area is written as a function of x, and then the actual equation for it is this beautiful thing right here. The 25 minus x cubed. Okay. Now at this point, Cody, is x the only variable in our equation?
Yeah.
Now you are done.
So just once that is the answer.
Yep.
Okay.
For part A, that's all it's asking us for.
Can we rewrite it
Yes, you can. Dylan? Hi. Got it?
Take a couple days.
Yes, it does. It's the first time you've seen anything like this. It always takes a couple days the first time you do these type of word problems. All right. Talking about the domain of A. What does that A stand for? Area. So can you have a negative area?
No.
No. All right. So what's the smallest number our area can be?
1.
1. Technically 0.
Zero.
Because you could have like a decimal. It'd be itty bitty, but it could still happen. Okay. So the smallest we could go is 0. So we'll say bracket 0. Now this rectangle has to exist under the parabola, correct? So does that mean that I could make it huge and ginormous and all the way out there? No. Okay, so what's like the furthest out that I could go along this parabola? 5. Very good.
Wait a minute. What about? Oh, I guess it only counts in one.
Because we are only in the first quadrant.
Yeah.
And Dylan, that's because they told us that up here.
Yeah.
Just in quadrant 1.
Alright.
Good. All right, get a graphing calculator, please.
Okay.
To the graphing calculators.
Hey, Maddie.
Do not take the ones that say need need batteries.
It's fine.
I don't know if like we got one that
No, just the ball players.
or
Thanks, Bill.
Now part C says graph A of x. So that beautiful equation we just came up with, that 25x minus x cubed, I'd like you to graph it, please.
Whoa. Oh, their windows all kind of.
What do you need your window as?
Well, we're going to have to figure that out.
Negative
This is like the
5,
most
5,
painful graph you've ever
right?
looked at.
or bigger.
It might have to end up being bigger. We'll see.
It won't have to change anything because mine's not.
This is a cubic because of the x cubed. So would we expect it to look like just a parabola?
No.
Would we expect it to look like a V?
No.
Would we expect it to look like boomerangs?
No.
What would we expect a cubic to look like?
Like an S.
Some sort of an S, maybe a little bit curvier than usual, but yes, an
Like,
S.
I don't know, it almost looks like two parabolas. Like
It's like a really
one going down and one going up.
There
Oh,
we go.
there we go.
So I
Okay.
set my window to negative, I don't know, I had to change the Y. And I did negative 50 and 50 and it just fit on there.
All right, what was that equation one more time, please?
25x minus x cubed.
X cubed. Okay, and what did you change your Y to?
My Y is negative 50 and 50.
Goes down, comes back up. Looks
What's
good.
your
not
X?
what I got.
What's your X?
I
did
did,
negative 10 and 10.
I just did negative 5 and 5, but
Yeah.
negative 10 and 10 should be good too.
What? How'd you get yours?
there's
Like,
no
mine
way.
is like super tall.
Look, that's because you need to change your x.
Oh,
Not necessarily. It's 25x minus x cubed.
Why it's so tall.
Can you see the top of your hill?
Yeah.
Can you see the bottom of your
Yeah.
hill?
Mine doesn't look like that.
It's like, what do you have your?
My x
Oh.
is much negative 5 and
not
5.
like that.
That's fine.
No.
that's what
Mine
I was
doesn't look
trying
like
to
that.
But that's because my x is from negative 5 to 5. Yours is from negative 10 to 10.
Oh.
Okay, so you're okay.
Negative 5. Okay. That
Should
was
I
a
do
little
5
bit
and 5?
You do not have to, no.
Yeah.
Okay. And so we've got our graph. Now,
I'll do it.
on part D, it's asking for what value of x is the area largest. What's another word for largest? Maximum, okay? Can you see a maximum on that graph? All right, find it on your graphing calculator. How do you do that?
Second trace.
Good. Second, trace, and then
Maximum.
max. So whenever they ask you to find the largest or most, they're asking for the maximum.
Let's see your calculator. You should get 2.8.
Yes, I did. Okay. All right, now, on your paper, underneath the part D, I want you to write down on the side the max. Dylan, say it one more time, please.
I got 2.88.
Comma.
48.1.
Okay, so write that down on your paper, please. Now, normally, an ordered pair is always x comma y. Agreed? Okay, now in our equation, our a of x equals 25x minus x cubed. We still have the x here like normal, but instead of y, what's in the y spot? A. Okay, so instead of y, or the y value now is representing our area A. So in part D, it says for what value of x is the area largest? So what value of x gave us the maximum? Good. So this is asking specifically for the x value. So part D is x equals 2.88. Part E, what is the largest area?
48.1.
Good. A equals 48.11. Very good.
Don't say that if I get my homework. Not gonna be very good.
All right, one more. Example 3. Dylan has got a blank line. You ready?
Yeah, I got it.
All right. A right triangle. So Gracie, last time it was a rectangle. This time we're going to draw a right triangle. Has one vertex on the graph of y equals x cubed.
I got it down.
Okay. X greater than 0 at x comma y, another at the origin, and the third on the positive y-axis. Express the area A of the triangle as a function of x. First of all, what equation did they give us? They gave us y equals x cubed. Very good. What does that look like? Just your basic tall, skinny s. Okay, so on the side here, I'm just going to sketch it out. What are some nice points on our basic cube?
0,
0, 0, 2, 8, 1, 1. Like something like that. Okay. All right. Now, we are going to draw a right triangle because that's what the problem told us we're dealing with here, is a right triangle. One vertex is somewhere on the graph of y equals x cubed for x greater than 0. Do you think x greater than 0 means I'm going to pick a point in the first quadrant or in the third quadrant? First.
Wait, I'm confused. Where are we at right now?
It says that one vertex of our triangle exists on the graph,
Oh, okay.
y equals x cubed, but for x greater than 0.
Okay.
And since they want it to be on x cubed, but where x is positive, that's this piece of it. So somewhere on here, it doesn't matter where we pick the point.
No.
No, all right, I'm going to pick it here. Okay. Where's another vertex for this right triangle? The origin. Okay.
X, Y.
And then, that's this one right here is the x comma y.
Oh.
And the positive y-axis. Now, can I pick that point to be right here if it's going to be a right triangle?
No, it has to be in line with X, Y.
Good, it has to be straight across from there. So we've got our right triangle there. Everybody okay with how we drew the right triangle? How do you find the area of a triangle? Half, base times height, good, okay. So normally we pick base and height to be B and H. What might be a better letter for base?
X.
X, and maybe instead of H for height?
Y.
Good. Got our equation? Are we done? Cody, are we done at this point? Why not?
What's the area of the triangle function of x?
Good. So the only variable that we want in this equation is what?
X.
Which means we need to get rid of.
Y.
And what can we replace y with?
X cubed.
Very good. Okay. So I'm going to write this as a equals 1/2 x times x cubed. So now my a of x, just using function notation, equals 1/2 x to the 4th.
Where do we get 1/2?
Well, area of a triangle is 1/2 base times height. Okay. So the 1/2 is still there. The x is still there, but we replaced y with x cubed. Gracie, were you asking another question? Okay.
Mine is a stupid question. I answered myself.
Okay. Now, at this point, they asked us to write the area as a function of x. Is x our only variable here?
Yeah.
Then we are done. Have they asked us to do anything else with it?
I hope not.
I don't believe there's a part like
Yeah,
A, B, C, or
No,
D.
there's B and C.
Oh, did I? I didn't have it on there. Okay, so what is the area if x equals 2? So on part B, they're asking us to find A of 2. So what do you do with the 2?
Plug it in.
Plug it in. 1/2 times 2 to the 4th? 8. Yes. Cohagen, you okay?
For largest areas, would it be like positive 30?
For the largest area, that's where you have to graph it and look for a max.
But there's just no back.
Yeah, max.
It's to the 4th. Oh, you're right. That one. Scratch that question. That question doesn't make sense for this one. You don't have to do part C. C. You can scratch C.
Okay.
Huh? All right.
Yes, sir.
Yes. Okay, this is the first time you've done word problems like this. It is going to be challenging. All right, so keeping that in mind, your homework is going to be numbers page 106, numbers 1 through 9 odd. So that way you can check yourself.